Welcome to Elevate Science Course 1, Topic 9, Earth's Surface Systems. We are continuing with Part 3, focusing on how groundwater changes Earth's surface. Please turn to page 411 in your textbook. Groundwater changes Earth's surface. When rain falls and snow melts, some water soaks into the ground. It trickles into cracks and spaces in layers of soil and rock. Groundwater is the term geologists use for this underground water. Like moving water, groundwater changes the shape of Earth's surface. Groundwater changes Earth's surface. Groundwater moves through cracks underground. It erodes limestone and forms caves. It also deposits calcite to make cave features. Groundwater erosion. Groundwater causes erosion by chemical weathering. In the atmosphere, rainwater combines with carbon dioxide to form a weak acid called carbonic acid, which can break down limestone. Groundwater may also become more acidic as it flows through leaf debris at the surface. When groundwater flows into cracks in limestone, some of the limestone dissolves and gets carried away. This process gradually hollows out pockets in the rock. Over time, large underground holes, called caves or caverns, develop. Groundwater erosion. Acid in rainwater dissolves limestone. Caves form as the rock breaks down slowly. Over time, huge caverns develop underground. Groundwater deposition. The action of carbonic acid on limestone can also result in deposition. Water containing carbonic acid and calcium drips from a cave's roof. Carbon dioxide escapes from the solution, leaving behind a deposit of calcite. A deposit that hangs like an icicle from the roof of a cave is known as a stalactite. On the floor of the cave, a cone-shaped stalagmite builds up as water drops from the cave roof, Figure 7. As water drips in caves, it leaves behind calcite. Stalactites hang from the ceilings, and stalagmites grow from the floor. For a hands-on activity, look at Figure 7 on page 411, Groundwater Erosion and Deposition. On the photo, draw a line from each label to the formation it names. Construct explanations. How do deposition and erosion shape caves? Outline your ideas in the table. Pause the video to answer the questions. Karst topography. In rainy regions such as Florida, where there is a layer of limestone near the surface, groundwater erosion can significantly change the shape of Earth's surface. Deep valleys and caverns commonly form. If the roof of a cave collapses because of limestone erosion, the result is a depression called a sinkhole. This type of landscape is called karst topography. The formation of karst topography happens over small to large areas and over short to very long time periods. Groundwater erosion starts with a single drop of water that dissolves a microscopic amount of limestone in seconds. After 100 years, groundwater might deposit 1 or 2 centimeters of calcite on the roof of a cave. Erosion might take thousands to millions of years to form a deep valley or huge cave system hundreds of kilometers long. The roof of a cave may very slowly erode over hundreds of years, but collapse within minutes to form a small or large sinkhole, as shown in Figure 8. Karst topography is caused by groundwater erosion and collapsing caves, forming sinkholes, caves, and valleys. It is common in Florida and other rainy, limestone-rich areas. Refer to Figure 8 on page 412 to interpret the diagrams. Circle the state that has the most karst topography. Also, interpret diagrams. Identify 2 states that have little karst topography. Finally, complete the reading check question. How does groundwater cause karst topography? Now we will be moving on to Lesson 4, which covers glacial and wave erosion. Please turn to page 416 in your textbook. For our notebook activity, we will consider 2 guiding questions. How do glaciers change Earth's surface? And how do waves change Earth's surface? Here is a list of important vocabulary to review and record in your notebook for this lesson. Pay special attention to the definitions of glacier, till, plucking, and longshore drift. This lesson will cover how glaciers and waves change Earth's surface over time through erosion and deposition, creating the landforms we see today. Please look closely at the image of the glacier on page 416. Consider the connect-it. Pause the video and read the questions. We begin with Part 1, Glaciers Change Earth's Surface. Please turn to page 417 in your textbook. Glaciers change Earth's surface. If you were to fly over Alaska, you would see snow-capped mountains and evergreen forests. Between the mountains and the Gulf of Alaska, you would also see a thick, winding mass of ice. This river of ice in Figure 1 is a glacier. Geologists define a glacier as any large mass of ice that moves slowly over land. Glaciers occur in the coldest places on Earth. That's because they can form only in an area where more snow falls than melts. Layers of snow pile on top of more layers of snow. Over time, the weight of the layers presses the particles of snow so tightly together that they form a solid block of ice. Glaciers are part of the cryosphere, which includes all the frozen water on Earth. As glaciers move slowly over land, the cryosphere interacts with the rocky upper layer of the geosphere that is known as the lithosphere. This changes Earth's surface through weathering, erosion, and deposition. When the ice of the cryosphere melts, it becomes part of the hydrosphere. A glacier is a large, moving mass of ice. It forms in cold areas where more snow falls than melts. Glaciers move slowly but dramatically change the land through weathering, erosion, and deposition. Academic vocabulary. Describe an interaction you observed and one you took part in. Be sure to identify the people and things involved in the interaction. Continental glaciers. A continental glacier is a glacier that covers much of a continent or large island. It can spread out over millions of square kilometers and flow in all directions. Today, continental glaciers cover about 10% of Earth's land, including Antarctica and most of Greenland. During ice ages, continental glaciers covered larger parts of Earth's surface. The glaciers gradually advanced and retreated several times, changing the shape of Earth's surface each time. Continental glaciers spread over large land areas like Antarctica and Greenland, flowing outward in all directions. They covered much of Earth during past ice ages. A valley glacier is a long, narrow glacier that forms when snow and ice build up in a mountain valley. High mountains keep these glaciers from spreading out in all directions, and gravity pulls the glacier downhill. Valley glaciers usually move slowly down valleys that have already been cut by rivers. Sometimes a valley glacier can experience a surge or a quick slide and move about 6 kilometers in 1 year. Alaska's Bering Glacier, shown in Figure 1, is a valley glacier. Valley glaciers are found in mountains and flow downhill through valleys. They can sometimes move very quickly in what is called a surge. Math Toolbox. Comparing glacier thickness. The graph shows the cumulative mass balance of a set of glaciers observed by scientists from 1945 to 2015. The cumulative mass balance is the total amount of ice the glaciers have gained or lost since 1945. The curve is always negative, so the glaciers have lost ice since 1945. The slope of the curve, how steep it is, shows how fast or slow the glaciers are losing ice. 1. Reason abstractly. What does a flat slope indicate? What does a steep slope indicate? 2. Interpret graphs. According to the data, the reference glaciers have melted and lost ice in every decade. In which decade did the glaciers lose ice slowest? In which decade did they lose ice quickest? Cumulative mass balance. Glacial erosion. The movement of a glacier slowly changes the land beneath it. The two processes by which glaciers erode the land are plucking and abrasion. As a glacier flows over the land, it picks up rocks in a process called plucking. The weight of the ice breaks rocks into fragments that freeze to the bottom of the glacier. Then the rock fragments get carried with the glacier, as shown in Figure 2. Plucking leaves behind a jagged landscape. Many rocks remain embedded on the bottom and sides of the glacier, and the glacier drags them across the land much like sandpaper, in a process called abrasion. land is worn away and deep gouges and scratches form in the bedrock. For most glaciers, advancing, retreating, and eroding the land are very slow events. It can take years for scientists to observe any change in a glacier or its effects. Sometimes, however, glaciers move unusually fast. In 2012, scientists determined that a glacier in Greenland advanced up to 46 meters per day, faster than any other glacier recorded. Although glaciers move and work slowly, they are a major force of erosion. They can take years to carve tiny scratches in bedrock. They can also carve out huge valleys, hundreds of kilometers long, over thousands of years. Through slow movement and erosion, glaciers dramatically change the shape of large areas of Earth's surface. Glaciers erode land through two main processes. Plucking occurs as the glacier picks up rocks, and abrasion happens as rocks scrape the land like sandpaper. Glacial erosion. Figure 2. Glaciers wear down Earth's surface by plucking and abrasion. Question 1. Interpret diagrams. Draw an arrow in the diagram to show the direction in which the ice is moving. Draw an X where you think abrasion is occurring. Draw a circle where plucking is happening. Question 2. Construct explanations. In your own words, describe the glacial erosion taking place in the diagram.